All right, so more system of equation word problems. This one is actually what they call a mixture problem. All right, so here it is. So how many ounces of a 20% hydrochloric acid solution and a 70% hydrochloric acid solution must be mixed to obtain 20 ounces of a 50% hydrochloric acid solution? All right, so pretty much, I'll give you like a little fancy drawing here. So you have a bottle of something, a solution that's 20%. You have another bottle of a solution which is 70% potent. Or you take these two bottles, you pour them in another bottle, right? You put the 20% in, you put the 70% in. They all mix together, and it makes a 50% solution. And there's going to be 20 ounces of all that. Okay, so you have two different bottles. One's a 20% concentrated, the other one's 70% concentrated. You pour them all together into one big bottle. Together, they make a 50% concentrated solution, and there's about 20 ounces. All right, so there's the visual behind it. And then I'm going to erase my fancy drawing here. I just want to give you a little quick drawing there. So, how many ounces? So I have 20 ounces altogether. So I'm going to let X equal the ounces of the 20%. I'm just going to put HA, hydrochloric acid. And I'm going to let Y equal the ounces of the 70% hydrochloric acid. All right, so I don't know how many ounces of each. All I know is I'm going to put them together into a bowl, into another cup, and I'm going to have a total of 20 ounces. So with that, my first equation is going to read that the ounces of the 20% plus the ounces of the 70% will give me a total of 20 ounces. The next part, a little tricky, okay? So I want to get a 50% solution of the 20% ounces, okay? So what I'm going to do here is I'm going to take the 20% solution times X amount of ounces plus the 70% solution, okay, converting those into decimal, of the times that many ounces, will give me the 50% solution times 20 ounces. All right, so the 20% solution times X ounces, the 70% solution times Y ounces will give me 50% of the solution at 20 ounces. And then once you have that, then those are your two systems of equations, and you could go about this any way you wish. You could use elimination, or you can use substitution, up to you. All right? You can graph this. Obviously, I wouldn't right now, but so I'm going to multiply this first equation by negative 0.2, which will then turn into negative 0.2x plus negative 0.2y equals negative 4. And then I'm going to add these two equations up. The x's will eliminate. 0.7 minus 0.2 is 0.5. Y equals 0.5 times 20. This is actually 10. 10 minus 4 is 6. Divide both sides by 0.5. And you get y is equal to 12 ounces of the 70% hydrochloric acid. If I have 20 ounces altogether, that means I have 8 ounces of the 20% hydrochloric acid, and that's what I mixed together. 18 ounces of the 70%, 8 ounces of the 50%, all together gave me 20 ounces total, and made a mixture with a concentrate of 50%. Alright, so here's another word problem. Plain child. This is similar to a boat problem that is something like number 34. Going downstream, upstream, going through the winds. Okay, so it's very similar in concept with that, right? So a plane traveled 828 miles to Toronto and back, right? And the upwind and tailwind, sometimes which you'll see in these questions. The trip there with the wind was 9 hours. The trip back into the wind, it took 18 hours. Okay, and find the speed of the plane. Okay, so the plane has its own natural speed. If you're traveling there, the wind might be blowing in the direction of the plane, in the direction that you're going, so it's going to increase your speed somehow. And then on your way back, the plane still has the same speed, but now the wind's going against you, so it's going to slow you down a little bit. All right, so that's the idea behind this. Okay, so this becomes a distance equals rate times time problem. So you've probably seen this in science already. Distance equals rate times time. All right, so this is going to come to something along that. So I'm going to write this as time, rate, and then distance. Right, so rate times time, times rate, same thing. Right, so I'm going to multiply those two. I'm going to multiply the time and the rate, and I'm going to get the distance of the plane. So some information is given here. So the plane traveled 828 miles to Toronto and back. So 828 there, 828 back. Okay. The trip there with the wind took 9 hours. So it took me 9 hours to go. So I'm going to go right there. What we don't know is the speed of the plane and the speed of the wind. So I'm going to do the rate is a combination of two things. The plane has its own speed, and the wind has its own speed. So I'm going to define two variables here. So we're going to let P equal the speed of plane and W equal the speed of the wind. And I know that. And then the last piece here I know is that the distance was 828. Now coming back, it took 18 hours to come back. The plane still had the same speed coming back, but what was happening is the overall rate or the overall speed of this plane was changed by the wind, right? The wind slowed it down because you're going against the wind this time, so the overall rate is not the same as the overall rate going there. Going back had a smaller rate, going there had a larger rate. But the distance was the same, assuming that they had the same path, okay? So now you have two equations, 9 times the quantity of P plus W equals 828. So I'm just going to write that there. 9 times the quantity of P plus W equals 828. And I could distribute the 9 here very easily, but what I'm going to do is I'm not going to distribute the 9. I'm actually going to divide by 9 here. And when I divide by 9, I'm left with P plus W equals 92. That's going to make my equation a little easier. Alright, so I just divided both sides by 9 here. And then the other equation I had was 18 times the speed, which is P minus W, again equal to 828. And this time I'm going to divide this by 18. And I get P minus W equals 46.
Why is it minus W? Why isn't it plus W?
So if you're going there, you're going with the wind. So the plus W, because the wind helps your speed. When you're going back, you're going against the wind. So the minus W means the wind is taking away from your overall speed. All right, and then this just becomes a system of equations. So by elimination, 2P equals 138. Divide by 2, divide by 2. And the P, which is the speed of the plane, is equal to 69 miles per hour. Right? So small plane there. And once you know that, then you could go back into any of those two equations. I could say 69 plus W equals 92. And you guess W is equal to 23 miles per hour.